Good afternoon, everyone. Today we're going to do a problem with bearings, where we have a situation of Batman and Robin leaving their campsite to go look for a nearby lake. So Batman first travels 1.1 kilometers at a bearing of north 60 degrees west, and then separately Robin travels 1.8 kilometers at a bearing of north 50 degrees east. And so we are asked to find the distance between them after they go off in their separate directions, and to find the bearing that Robin would have to walk to get back to Batman from that point. So let's start by drawing a diagram. So we'll have, let's say, their campsite. Then Batman goes off 1 kilometers north, 60 degrees west. So I'm going to draw my north and south dotted line. North 60 degrees west, west is over here, and of course our east is over here. So north 60 degrees west is something like this, let's say, roughly. So that's a 60-degree angle. This is Batman's location. And we'll say that this side length is 1.1 kilometers. Next we have Robin traveling 1.8 kilometers at north 50 degrees east. Now we're going east, and so we'll do 50 degrees, something like that, and 1.8 kilometers, so Robin will be somewhere over here. Does that make sense? Does that look okay? Yeah, let's say that's roughly 60, that's roughly 50. That's not perfect, but reasonable enough, let's say. And so obviously we can match their two endpoints with the third side length, right? And so we have a nice triangle now. We also know that this side length is 1.8 kilometers. So we have an angle here of 60 plus 50, meaning the entire interior angle of the triangle is 110 degrees, meaning an obtuse triangle. So where can we go from there? Well, we have two side lengths and the angle in between. So to get the third side length that is opposite from the angle, we can use our trusted cosine law. Let's label this side D for distance, let's say. So then we can write our cosine law, which states that D squared will be 1.1 squared plus 1.8 squared minus 2. You guys know the drill. Times the cosine of 110 degrees. And now we don't want D squared, right? We just want D. And so D will be the square root of all of that. And then you can throw that into your calculator. And you'll find that D is equal to presumably 2 point something. Square root, be careful with your brackets when you're plugging all this into a calculator. So easy to make silly mistakes along the way. And I have 2.4 for the distance between Batman and Robin, roughly at least 2.4 kilometers. And now that's part A done. So to find the bearing that Robin would have to take to walk to get back to Batman, one thing that I always recommend my students do is make a new axis of north and south again. So we're leaving from Robin's place, or we're going from Robin to Batman. So let's draw our dashed north-south line, because we know that these two lines are now parallel, and so we can apply some of the geometry that we've studied earlier. We can see a Z theorem popping out at us, like so. So the interior angle here of 50 is also found here. And so now we know that Robin is going to go, this is 1.8 kilometers, so she's further up, she's further ahead, because they both went north. So it sure does look like Robin is further north than Batman. Robin also went less east than Batman went west, right? 60 degrees west, 50 degrees. So Robin should be further north. My diagram isn't, that's not making it pop out at us, but Robin certainly is further north than Batman, so she should have to go south and then some amount towards the west. And so our answer should reflect that in the end. So here, I should finish this off. I should finish this off. D is roughly 2.4. So now what we need to find is this interior angle of our triangle there, because then our bearing will be, from Robin's standpoint, south this many, all of this angle, degrees west, right? 50, that is already there, plus however many degrees are inside this space. So let's label this theta, as we often do whenever we're looking for missing angles. And now we know we have theta and its opposite side length, and we have 110 degrees and its opposite side length. And so we have an oblique triangle here, so we can use our sine law. Maybe I'll do that here. So now using our sine law, we have sine of theta over 1.1, right? Always going across over 1.1 is equal to the sine of, let's use 110 degrees over opposite side is 2.4. I trust that you guys know how to algebraically solve this, right? We want to isolate theta. So first times by 1.1 on both sides. And then that'll be sine theta. And so to get theta by itself, we know we'll have to take the inverse sine of both sides. And so we'll find theta to be the inverse sine of this stuff, i.e. 1.1 times the sine of 110 degrees, all divided by 2.4. And throwing that into your trusted calculator, you'll find an angle theta of inverse sine of 1.1 times sine of 110 degrees. Again, be careful with your brackets. And when you're putting in sine of 110, make sure, I'm guessing your calculator's gonna make you put brackets around the 110, and then outside of that, dividing by 2.4. Again, be very mindful of that. And if you do it properly, you should find an angle of 25.5 degrees for angle theta. And so that means that this angle inside the triangle, right, because we use the sine law inside the triangle, so theta here is 25.5 degrees, right? And now it's probably clear that our bearing is going to be south, because she has to go down a little bit, and then 50 plus 25.5 degrees west to get along this path to rejoin Batman at his location. And so 50 degrees plus 25.5 degrees makes 75.5 degrees. And so for part B, Robin has to walk 2.4 kilometers at a bearing of south 75.5 degrees west. To rejoin Batman. And there we have it. Okay, so hope that helps. Thanks for watching.